This video is about percentage yields. Let's consider this reaction. Magnesium plus oxygen creates magnesium oxide. How would you carry out this reaction in real life? Most likely it will look something like this. Get a tripod, place a crucible over it, the magnesium goes into the crucible, begin heating it using a Bunsen burner. You can also cover the crucible with a lid so that it can heat faster. Now, periodically you're going to lift up the lid so that oxygen from the air can enter and react with the magnesium to form magnesium oxide. To calculate percentage yield, you're going to do actual mass divided by theoretical mass times 100. The theoretical mass comes from your calculations, whereas the actual mass comes from the reaction that you carry out in real life. Another word for actual mass is experimental mass, or the mass that you obtain by doing the experiment. Let's have a go at calculating percentage yield. Suppose the question says, if we had 48 grams of magnesium, what mass of magnesium oxide would we produce? This is a basic reacting masses question. First of all, you want to make sure the equation is balanced. Next, we're going to use our knowledge of reacting masses to calculate the mass of magnesium oxide produced. So first, you're going to divide by the MR of magnesium, which is 24. That gives you 2 moles. Next, we're going to compare the ratio of magnesium to magnesium oxide. So 2 to 2 means it's a 1-to-1 ratio, so the moles will be the same. Finally, we're going to times it by the MR of magnesium oxide, which is 40, and that gives us a final answer of 80 grams. What we just calculated was the theoretical mass, meaning if we had 48 grams of magnesium and it all completely reacted, we would produce 80 grams of magnesium oxide. However, we know that in real life, chemical reactions don't go as planned. Susan had 24 grams of magnesium. Her experiment produced 60 grams of magnesium oxide. Let's see if we can calculate the percentage yield of her experiment. So we're going to use the formula that we looked at before, actual mass divided by theoretical mass times 100. So we already calculated that for 24 grams of magnesium, you can theoretically produce up to 80 grams of magnesium oxide. Susan produced 60 grams, so this is her actual mass. Putting this into our equation should give us an answer of 75%. Okay, so now we're going to talk about why reactions aren't always 100% yield. Now, by the way, if you forget which way around it is, a good way to remember is this. Out of the 2 numbers, the larger one is always at the bottom, whereas the smaller one's at the top. Remember, you can never get more than 100% yield, so if you get the wrong answer, try flipping around the numbers and see if it works. So why is it difficult to get 100% yield? One could be because it could be a reversible reaction. In the reversible reaction, some products can turn back into reactants, meaning the amount of product you produce is lower than expected. The second reason could be because if we did not allow the magnesium to heat up and react with oxygen for long enough, that would be an incomplete reaction. So making sure that you allow the reaction to go to full completion is one way that you can maximize yield. If the reaction is stopped too early, then you won't produce as much products. Sometimes products can be lost, especially if you're transferring from one beaker to another one. Sometimes a chemical reaction produces side products which use up your reactants, and this reduces the amount of product that you can produce. Hey guys, if that video helped you, support our channel by liking, subscribing, and sharing it with your friends. And more importantly, if you still have questions, drop a post on our forum at ExamQA.com, where I will personally be there to help answer your questions. Mohammed signing out.